about a round robin scheduling algorithm. So here we are considering the time quantum. Based on that time quantum, we are allocating the processors to the CPU. Every processes will be allocated based on the time quantum itself. So every process will have the equal time quantum. So see here. So here the time quantum is 2 units here, right? So the process P1 arrived at the 0th time, and the burst time of this P1 is 5. So the process P1 is 5, right? But the process 1 will complete only 2 units of the its task. So the so you see here, the burst time of the P1 process is 5. So and the quantum time is 2. So the process P1 be allocated to the CPU first, and it only completes the 2 units of work first. Even though the burst time is 5, it first completes only 2 units of work. So then again it will be sent back to the ready queue. Okay, next the P2 process will be arrived. So now the burst time of the P2 is 3. So this P2 will also perform as 2 units of work, 2 units of execution, and again the P2 will be sent back to the queue. Okay, ready queue. So then the P3 process will be allocated. So is allocated. So the burst time of this P3 is 1. So it will complete this in the first execution itself, right? So the P3 execution is done. Now P4 now the P4 process will be allocated. Now this P4 process also execute only 2 units of work at the first time. Then again this will be sent back to the ready queue. Now see from the first P1. So already 2 units of work is completed. Now 3 units of the execution is pending. Now again 5 minus 2, 3, right? 5 minus 2, 3. So 3 units of execution is pending. Now again it will complete only 2 units of the task. Okay, then again it will be sent back to the ready queues because still 1 unit of work is pending. Okay, now the P2 process will be allocated. Already two units of execution is done. Now remaining one P2 will need only 1 unit to complete this execution. Now P3 already executed. Now P4 already 2 units of completed already complete 2 units of work. Still 2 units of execution is pending. Now P4 completes its execution. Now 2 units of execution. No. Okay, now P1 only remain. Only the P1 processes will remain. So it need 1 unit of time to execute its execution. Each process completed its execution. Right. Here, then so here we are declaring the so here first using the variables and arrays to store the information about the processes. They use to number then n is for number of processes, qt for quantum time, qt is for quantum time. Then initially the count will be 0, then burst time, waiting time, and total turnaround time, and the remaining burst time. So the total turnaround time and the total waiting time initially equal to 0. Then we are taking the input from the user. Yeah, right. So burst time, that is the number of processor and the burst time. So after that we are taking the time quantum. Okay. So if it is true, this part will be executed. So here we are using the count variable to track the number of processors that have completed its task. Then initializing the quantum time to the temp variable, that is temp time. Then check if the remaining burst time for the current process is equal to 0. If it is true, then the process has completed and count has incremented. Then check if the remaining burst time is greater than the quantum time. If it is true, then deduct the time quantum from the remaining burst time. Okay. Else, if the remaining burst time is greater than equal to 0, then the remaining burst time equal is set to 0. Okay. Then update the turnaround time for the current processor. Okay. Then if n is equal to count, this loop continues until the process have completed. Okay. Next we are calculating the waiting time, the turnaround time, and the total waiting time. So how we are calculating the turnaround time? Sorry. So how we are calculating the wait time? So how we are calculating the waiting time? That is turnaround time minus burst time. So turnaround time, it is 13 minus burst time. 13 minus 5, 8. 10 minus 3, 7. 5 minus 1, 4. 12 minus 4, 8. After that, we are calculating the total turnaround time. Total turnaround around time will be calculated by adding this turnaround time. 13 plus 10, 10 plus 5, 5 plus 12. Then we are calculating the total waiting time. So we are taking the total of this waiting time, that is 8 plus 7 plus 4 plus 8. After that we are displaying the result on the monitor. So here we are calculating the average turnaround time. So how we are calculating the average turnaround time? So total turnaround time divided by n. So total of this divided by number of processes. Similarly, average time will be calculated, average waiting time will be calculated by taking the total of this divided by n.